Hey Ramblers, this video is going to cover a new topic called isometry,
or what some of you may have come across as called rigid transformations. Now in this class we're going to learn about three
rigid transformations. The first will be translations, or what you may have heard called slides. The second will be reflections, or what you may have called flips. And finally, the third one will be called turns. The third one is rotations, which are also commonly called turns. In this video, we're going to come across quite a few vocabulary terms. We're going to talk about what congruent figures are, what tick marks are. Once we get into the transformation, we'll talk about pre-image and image, and also line of reflection and axis of symmetry. So please, I need you to take your time watching this video, pause it often, take good notes, and so what I'm talking about sinks in. All right, let's start off by talking about our first vocabulary term, congruency. Okay, before we start talking about isometry, we need to understand what congruent figures are. And congruent figures, since the first vocabulary word, are just figures that have the same size and shape. So we might say that segment AB is congruent to segment CD. And that would be true if they had the same length. So we would write AB, segment AB, is congruent to CD. And the congruency symbol is just an equal sign with a little tilde over it. You might also notice that I've put a little dash in the middle of AB, in the middle of CD. That's kind of a visual way of representing congruency too. You'll notice that will become in very handy as we get into more complicated diagrams. But you can have other things that are congruent too. You might say that an angle, maybe I have angle A is congruent to angle X. And we would say angle A is congruent to angle X. And you might use a tick mark to visually represent that by just drawing a little arc in the angle and maybe putting in a dash or two. But as long as they're consistent from one congruent angle to the other one, you would know that those two angles are also congruent. And this also works with figures. You could have a triangle be congruent to another triangle, and we'll do a lot of work with congruent triangles in this class. But you might have triangle ABC congruent to triangle XYZ, and you would write triangle ABC is congruent to triangle XYZ. And what that means is that all the corresponding sides would be congruent, and all the corresponding angles would be congruent. So you can have congruent angles, you can have congruent polygons, and you can have congruent segments. But things like rays can't be congruent because I guess you could say all rays are congruent. They go off to infinity. Same with lines. So really we keep it to these three things that are congruent. Now let's see how that applies to isometry. So in a translation, we're moving an object horizontally and or vertically without turning, reflecting, or changing the object's size. So the new object is going to be congruent to the original. Now it's important to note that the new object is called the image and the original is called the pre-image. You'll also notice that the image has the same labeling of the corresponding points as the pre-image, but we've added a tick mark to it, an apostrophe, and we call that prime. So we would say triangle ABC is congruent to triangle A prime, B prime, C prime. And all that would have changed is that the location of triangle ABC has now moved over horizontally to the left and vertically down, but is still the same size. So we say that the two are congruent. And we say that triangle ABC is mapped onto triangle A prime, B prime, C prime. And the rule would be that it moved horizontally -1, 2, 3, 4, 5, 6, -6 places, and it moved vertically 1, 2, 3, 4, -4 spaces. And so the way we note that is that we just write triangle A prime, B prime, ABC is mapped onto triangle A prime, B prime, C prime using that arrow, where ABC is the pre-image and triangle A prime, B prime, C prime is the new image or just the image. Okay, let's move on and talk about the next kind of translation. The next type of rigid transformation is called reflection or flip. And here we're taking an object, the pre-image, and reflecting it over a line called the axis of symmetry, also known as the line of reflection. Now, these might at first look as just like a slide. I mean, it appears that A just was moved vertically -2 units and B was moved -2 units. But you can see that point C would not follow that same rule as it was moved down to C prime. So there was a horizontal line here. It's actually the x-axis where we reflected the pre-image triangle ABC over the axis of symmetry or the line of reflection, the x-axis, to form the new image triangle A prime, B prime, C prime. Okay, rotations or turns are when we take a pre-image like triangle ABC there in the first quadrant and rotate it either clockwise or counterclockwise around a fixed point called the axis of rotation. In this case, the pre-image, triangle ABC, was rotated about the origin. And you can see that the rotation was in a counterclockwise movement, and that was a number of degrees. Now, in this case, that was going to be 90 degrees. But we'll get to all that when we get into the next video and when we see each other again. We're going to start talking about how to determine what the new coordinates are based upon the rule and where the pre-image started. So all that's coming up. So Ramblers, I hope that you learned a lot from this video. We talked about rigid transformations. There were 3 kinds. There were translations, there were reflections, and there were rotations. We came across some new terms like congruency, tick marks, the rule of a isometric transformation. We talked about pre-image and the line of reflection, which is also known as the axis of symmetry, and the axis of rotation. Okay, so you got a lot of material in there. I hope you took good notes, and I hope this helped. Okay, see you later.